Hey guys, let's review for your semester exam. Now, this is going to be kind of a long one, but just stick with me. Hopefully, you guys can try a couple of them. It makes sense still. It may have been a while, but let's get back into what we need to know for our test. So, starting off with transformations, remember that the negative out front is your reflection, your A is your stretch or shrink, your H is left or right, and your K is up and down. So on this one, it gives you your parent function, okay? It tells you that there's a reflection. So we know that's the negative out front. It tells you that it shifts 3 right, okay? So we know right and left is our H. So we know our H has to be 3 right is negative, has to be -3. And then our reflection out front has to be a negative. Okay, so when we go to write the equation, we put a negative out front. We have 1 over x, and your h always goes with your x, so -3. Now let's look at this next question. It is the square root function. It says it shifts right 4. We know that's our h. Okay, 1 down, we know that's k. And then a shrink by 1/2, we know that's a. Okay, so we can rewrite the equation. We have a 1/2 out front. We still have our square root of x. For our 4 right, remember if it's going to the right, it's negative, so -4 underneath, and then 1 down, so it's -1. Okay, now let's try one more together. So we have 2 to the power of x. It says there's a reflection over the x-axis, so we know that's a negative out front, and it shifts 2 units to the left, so we know that's our h. Okay, so our base is 2 to the power of x, so we're going to have a negative out front, 2 to the power of x, and then with that x, we're going to have this +2 for h. Okay, and these typically go in parentheses. All right, so go ahead and pause the video, and I want you guys to try these 4, 5, and 6. Okay, let's go ahead and check your work here. This is what I got. And I labeled all the things A, H, and K like we just did. Okay, so now let's look at this example here. It says describe the transformation. So notice it has an A, it has a K, it has a -4. So it's only asking us to identify what the number is doing. So for this -4, we know it's next to an X, so it's our H value. And we know when H is negative, it's going to the right. So this equation moved right 4. Okay, so I want you guys to do the same thing. Find the number that it gave you and then determine how it moved, left or right. So go ahead and push pause. Okay, and this is what I got. The 3 out front matches up with A, so it's a stretch by 3. The +5 is after your X. It's not in parentheses, so we know that's a K, so it goes up by 5. So let's go ahead and look back at a polynomial graph, and let's try to label some of the things. So let's start with our relative max. Remember, a relative max means it's a high point, but it might not be the highest point, especially because the graph keeps on going up. And then our relative min, remember it's a low point, but may not be the lowest point. But because this graph, the end behavior goes up, we remember that this is our absolute min here. Okay. And then for our x and y intercepts, that's just where it touches the x-axis, where it touches the y-axis. So for our x-intercepts, we have 1 here, 1 here, 1 here, 1 here. And then for our y-intercepts, it's right here. It's the same as our x-intercept at 0, 0. Now this equation is a little bit difficult to write an equation for, so let's just go ahead and identify what that parent function is. Okay, so it's an exponential function. So it has some base to the power of x. So f of x equals some base b to the power of x. Okay. Now, moving on, let's look at this graph right here. So it says determine what the transformations would be. So we started at f, so you're going to want to find one point on f. Let's say right here. We're going to find the same point on g right here, and then we're going to see how it moves. So notice it goes 1, 2, 3, 4 down, and it goes 1, 2, 3, 4 to the right. So if we were going to write the equation, f of x, g of x equals, okay, so we have our f of x, and in there with our f of x, since it moves to the right, 4, we're going to put minus 4. And then because it moved down, we're going to put minus 4 outside as well. Okay, so that just explains how our graph moved. It moved right 4, down 4. All right, moving on to the next page. I would like for you guys to go through all the ones on this page, try to describe all your transformations, try to graph all of them. So go ahead and push pause. Okay, so I identified all these transformations. I also graphed all of them. So let's start with this rational function. Remember, we have those rules and they're going to be on your test. So here's the rules for horizontal asymptotes. So let's start there. Remember, you want to look at the degree on top and the degree on bottom. So you're looking at the biggest exponent with your x. Notice that we have a degree 1 on bottom and 0 on top. So our denominator is greater than our numerator, which means that's example 1. So we're going to say y equals 0. Okay. And then recall for our vertical asymptote, we want to set the bottom equal to 0. So for your vertical asymptote, we want to say x minus 2 equals 0. We're going to plus 2 to both sides. So x equals 2 is our asymptote. So we could draw that on our graph. Let's see, we'll do yellow for our horizontal asymptote. That's right here. And then I'll do pink for our vertical asymptote, which is on x equals 2. Now remember, your domain and your range goes with your x's and your y's. So we're just going to say x does not equal 2 and y does not equal 0. Okay, so now looking at this question, how can we tell if it's growth or decay? So let's look at our table. Our y's are getting smaller. So if our y's are getting smaller, we know that's a decay. Okay, and then if you're writing your equation, recall that this type of function is y equals a parentheses b to the power of x, where your b is your growth or decay factor and your a is your y-intercept. So looking here for your a, we want to look when x equals 0. So this is your a at 1. And then for your b, you want to look at the pattern, like how are we changing? So notice from here to here, we're multiplying by 1/2. From here to here, we're multiplying by 1/2. So that's your pattern. Your pattern is your b. Now, to write our equation, we have y equals 1 parentheses 1/2 to the power of x. And then for this one, we have a horizontal asymptote at y equals 0. Now let's move on to this next function. Remember, these are square root functions, so they have an endpoint. That endpoint is right here on the graph. okay? In order to find that endpoint, we just want to look at our transformations, how far it moved left or right, up or down. So because it moved right 4, up 1, our endpoint is 4, comma 1. And notice it never touches your x or y axis. It's always greater than your x-axis, always greater than your y. So there is none. There's no x-intercept and there's no y-intercept. And then for domain and range, we want to use the numbers from your endpoint. So x is greater than or equal to 4. Y is greater than or equal to 1 because our graph is to the right and it's going up. Okay, so another equation, our critical point, we're still looking at how far it moved left, right, up, or down. So since it moved left 1, it's -1, comma, +5. And for these functions, the domain was all real numbers and your range was all real numbers. Okay, let's go ahead and take a second to look at all of these answers. Okay, so for your critical points, remember you want to look at how far it moved left or right, up or down. For your domain and range, it's all real numbers for a cubic function. For that square root function, if it's going to the right, it's greater, left, it's less than. If it's going up, it's greater. If it's going down, it's less than. And you just want to use your critical points for those, or your endpoint on that one. And then remember, it's growth if it's getting bigger, decay if it's getting smaller, and that A value is your y-intercept. And then for any rational function, remember you have your set of rules. And when you're trying to draw your graph, you want to draw it based off of your asymptotes. Okay, so go ahead and pause the video, try to describe all the transformations and graphs for 17 and 18. Hopefully you got what I got. The first one was a reflection over x and it moved up 2, and then the next one just moved up 5. Okay, and then hopefully your graphs look like my graphs. All right, so now going back to your critical point, it moved up 2 and it didn't move left or right. So we have 0, 2. And then for your domain and range, it's the same thing as the cubic functions, which was all real numbers. And then looking at this graph, your asymptote is horizontal. Okay, so we have a horizontal asymptote right here. This comes, for these functions, it comes from your k value. So we just want to do y equals k, and in our case, our k is 5. So y equals 5 is our answer for that one. Domain is all real numbers, but your range is y is greater than 5 because it approaches but never touches 5. So those are what that looks like. Now here are the rules for log, and I would pause this, write it down, maybe put it on your note card, and then try to do these questions. So go ahead and pause it, write these rules down, and then do all of the questions for 19 and 20. So go ahead and check your work for 19 and 20. This is what I got. Okay, notice that on those expanded forms, you have 2 rules. Okay, you have the quotient rule, and then you also have the power rule. And then on the bottom one, you have the power rule, and you also have the product rule. Okay, so you want to make sure you write it out for each one of the different rules. Now let's go ahead and look down here. So we're going to try to solve for x using logs and exponentials. When we're solving for x, you want it to be x equals. We want to isolate for x. So looking around, find where your x is. That's where you want to get it isolated. You want to get it by itself. Okay, so the first 3 are pretty straightforward. So go ahead and try those first, and then I'll explain the next 3. Go ahead and pause it. All right, here's what I got. Hopefully yours looks similar to mine. Okay, so now let's go ahead and take a look at number 20. 4. Okay, so we notice that our x is in the exponential up there. So we need to isolate this first. So that means we have to move a -5 and a 6. And anytime that number is in front of something with no plus, minus, or division sign, then you know that's multiplication. So we're going to do the opposite of subtraction, the opposite of multiplication. So I'm going to plus 5 to both sides. And I get 25 equals 6 to x. Then I'm going to divide by 6. Okay, so I have 25 over 6 equals 2 to the power of x. Now I have my exponential by itself, and I can rewrite it as a log. Okay, so we have log base 2 of 25 over 6 equals x. And then now that we have our x by itself, it says x equals, we can just plug this into our calculator and get our answer. Now let's look at number 25. Notice number 25 has something similar on both sides, and that's the same base. And because it has the same base on both sides, we can just ignore our bases and set our exponents equal to each other. So we have 2x minus 1 equals 7. And then you just solve like we normally do, plus 1 to both sides. 2x equals 8, and then divide by 2. So x equals 4. Now we have our x equals by itself, and then we're finished solving that one. Now let's take a look at number 26. Okay, we have x's in both exponentials, so we need to get the same base. And remember that 81 can break up into 2 9s, 9 times 9. So we can rewrite 81 as 9 squared. So we have 9 to the power of 3x equals 9 squared x minus 4. When we have it like this, we want to go ahead and distribute the exponents. That's our exponents rule. So we have 9 to the power of 3x equals 9 to the power of 2x minus 8. Make sure you get it all the way to the 4. Another way to do that is to do the box method. 2x minus 8. Okay, now that our bases are the same, we can go ahead and ignore them, and we have 3x equals 2x minus 8. I'm gonna minus 2x to both sides to get our x's all the way on the left, and I get x equals -8. Okay, so that's it for this page. Let's move on to this one. So recall, for your exponentials, your asymptote is x equals k. And for logs, your asymptote is y equals h. It's positive if it moved to the right, negative if it moved to the left. And it's 0 when there's no h or k. So go ahead and try to do 27 through 30. Go ahead and push pause. Hopefully you got what I got. Y equals 6, y equals 0, x equals -2, x equals 0. And then recall, for these b's, that's your growth or decay factor. Those are those exponential equations. Okay, so if it is growing, we want our graph to go up. It's increasing from left to right. And when it's a fraction, it's decaying and it's going down from left to right. Okay, so I want you guys to go ahead and try to identify if it's a growth or decay factor. So remember, you're looking for your b, and you're trying to see if it's greater than 1 or if it's between 0 and 1. If you're not sure, you can graph it, see if it's going up from left to right or down from left to right. So go ahead and push pause. Oh, and actually go ahead and answer number 33 too. That's pretty straightforward. It's just, what are the inverse functions? Try to see what you remember. Okay, here's what I got. I got growth, growth, decay. Then the inverse of a log is an exponential, inverse of a cube root is a cubic, and the inverse of a quadratic is the square root or radical. So now let's solve these equations. So we have some square roots and we have some cube roots, but it's the same thing. You want to isolate the radical, square or cube both sides, which is the opposite. Isolate for x, and then plug that into your original equation to see if it's true or false. Okay, so why don't you guys try step one, pause the video, try step one for all three of those questions. Okay, hopefully you guys got, you added 5 to both sides and divided by 3 to get 35 by itself, and then you just minus 1 to both sides to get the cube root by itself. So let's go ahead and work out the rest of the problem together. So we want to square or cube both sides. So this first one, we're going to go ahead and square it because it's a square root. So we have 2x minus 7 equals 9. We're going to plus 7 to both sides. 2x equals 16 and divide by 2. So x equals 8 is your final answer on that one. Let's look at this one. So we're going to square both sides again. 2 squared is 4. So we have 8x plus 1 equals 4. Minus 1 to both sides. 8x equals 3. Divide by 8. So x equals 3/8. Okay, and let's do this last one. Notice it's a cube root, so I'm going to go ahead and cube both sides. Okay, and I get 2x equals 64. Divide by 2. X equals 32. Hopefully your algebra has gotten better over the year and those feel pretty straightforward. So finding the inverse, remember these are the steps. You want to rename the function y, switch your x and y, then isolate for y, then you're going to rename the function. So try step 1 and 2 for 37 and 38. Just rename the function y, switch your x and y, and we'll go from there. Okay, hopefully you got what I got here. So notice instead of writing f of x, I wrote y, then I switched my x's and y's. Now we're gonna solve it. So the cube root is here, so we need to do the opposite of a cube root to get rid of it. So we're gonna cube both sides. So we have x to the power of 3 equals y minus 2. We're still isolating for y, so I'm just gonna add 2 to both sides. So y inverse equals x cubed plus 2. Now let's check this question. So notice we have this log. We want to get that by itself first. So in order to get this by itself, we need to move this minus 1. So I'm going to add 1 to both sides. And I get x plus 1 equals log base 2 y plus 5. Okay, and then we're going to do 2 to the power of x plus 1 equals y plus 5. Just rewrite it, and then minus 5 to both sides. Okay, so we're going to say f inverse x equals 2x plus 1 minus 5. Okay, so those are inverses. Let's work on these next two questions, 39 and 40. Try to find your x and y intercepts. Remember, you can graph it. You can trace your graph. You can plug in 0 for your x's, plug in zeros for your y's, find it that way. Find your y-intercept by making a table, looking for x equals 0, whichever way makes most sense to you at this point. Okay, so here's what I got. Now let's look at our domain and our range for these two questions. So 2 to the power of x, remember that's an exponential and it is growing, it's going up. So those have all real numbers for your domain, and for your range, our y is greater than 0 because that's where the asymptote is. And then for logs, it's going to be the opposite because they're inverses of each other. And our x is going to be equal to, I'm sorry. Our x has to be greater than how far it moved. So it moved right 1, so it has to be x is greater than 1. That comes from your h value there. Now, that's it for this page. Let's go on to this next question. So recall critical points is your h and k. So go ahead and try these. Remember, if it moved left, your h is going to be opposite. It'll be negative. And if it moved right, your h is going to be positive. So I got -5, 0, -3, -2, 1, 2. And then looking at these rational functions, I want you guys to try to find your x-intercepts and your horizontal asymptotes. Remember, here's your rules for horizontal asymptotes. So pause the video and try that. Okay, so here's what I got. So on that first one, they were equal to each other. So we're looking at the number in front of x squared and on the top and bottom, which is -3/1. Okay, so let's go on to the next page to find your holes and your asymptotes in your domain. So for this question, we have to factor the top and bottom. The top is just one term, so it doesn't need to be factored, but that bottom, if we recall, that's our difference of squares. So to factor it, this is going to be equal to -3x squared over x minus 2, x plus 2. For your holes, you look for something on top and bottom that cancels, but because nothing cancels, you know there's no holes. All of these rules are given to you on the test, so if you don't remember, you don't need to write them down. Then for your vertical asymptote, you set the remaining factors in the denominator equal to 0. So we want to do x minus 2 equals 0 and x plus 2 equals 0. So that gives us x equals +2 and x equals -2 for your asymptotes. Then your domain is x does not equal your holes or your asymptotes. So x does not equal 2, x does not equal -2. That was probably a little bit fast, but let's go ahead and try this next one. Okay, notice the top is already factored. The bottom is going to be your diamond method. So we want to label our A, B, and C. So A equals 2, B equals 3, and C equals -2. So in order to do our diamond, we have A times C on top, B on bottom. So we have -4 on top, 3 on bottom. And then we're looking for two numbers that multiply to get -4 and add to get +3. So we have 2x on top. And then I know 4 and 1 can make 3, okay? And we need a +3, so I'm going to put +4 and a -1. And then the only thing we have left to do is simplify. So notice this 2x over 4 can simplify to 1/2. So this one, let's go ahead and erase these. We don't need those anymore. This one is going to simplify to 1x over 4. So to write our parentheses, we have x plus 4 and 2x minus 1. Now let's rewrite our function. We have -2 x plus 4 over x plus 4, 2x minus 1. Notice we have an x plus 4 on top and bottom, so that's going to be our hole. So for our holes, we have x plus 4 equals 0. So x equals -4 is our hole. And then for our vertical asymptote, we're going to take what's left, which is the 2x minus 1. So for our vertical asymptote, we're going to say 2x minus 1 equals 0, plus 1 to both sides, 2x equals 1, divide by 2, x equals 1/2. Okay, so remember for our domain, it's just x does not equal your wholes and x does not equal your asymptote. That was a hard unit for us, but moving on from that one, let's go ahead and identify some things. So we can identify our vertical asymptote on here. That's just right in the middle. Our horizontal asymptote, that looks like it's right about here at 1. And our whole is right here. Our x-intercept is where it touches the x-axis. And then our y-intercept is where it touches the y-axis. And then recall it's just x does not equal your wholes or vertical asymptote, which was at -1 and -3. So x does not equal -1 or -3, and y does not equal 1. Okay, so let's go ahead and take a look at some word problems. Remember, it's 1 over person A plus 1 over person B equals 1 over the time together. So Sarah can do the job in 4 hours, John can do the job in 5 hours, and Mike can do the job in 6.5 hours. And then what would it take for them to do it together? So we have 1 over 4 plus 1 over 5 plus 1 over 6.5 equals 1 over t, which is our unknown. And then remember, to solve it, you're going to multiply each fraction by the common denominator. So multiply everything times 4 times 5 times 6.5 times t. Okay, so then you just see what cancels. So on that first one, the 4's cancel. So we have 1 over 5 times, we have 5 times 6.5 t plus 4 times 6.5 t plus 4 times 5t equals 4 times 5 times 6.5. Okay, so you just add up all those numbers and that's what you get. For this next one, you want to identify your P, N, R, and T. So we started with $80. That's your principal. Your rate is 5%, so 0.05. And the number of times is 12 because it's monthly. And it's asking what it would be after 5 years. So you're just going to plug all that information into the equation and plug it into your calculator. I am not going to do that part. Let's go ahead and look at number 47. So for this one, you want to add your list in spreadsheets. And in order to do a power regression, you press menu 419. Make sure you select that X and Y in the table and then plug in your A and B into the equation. So go ahead and check your work with me. This is what I got. Hopefully you got the same thing. Notice our exponent is 1/2 or 0.5, and anytime you have x to the 1/2, it's the square root. So you can write it either way. Now let's look at this one. These are rational functions, and in order to graph them, it's best to graph your vertical and horizontal asymptotes first. So your vertical asymptote on this first one is at 4. Because it moved to the right 4, and this one is at 0 because it didn't move left or right. And then for your vertical asymptotes, this first one is at 0 because it didn't move up or down. The second one is at +4 because it did move up or down. Okay, and then just go ahead and draw in your lines. Okay, so hopefully this is what yours looks like. I know this is a lot of information. Do your very best to study, practice questions, pause the video, make sure you're actually trying to work some of these questions out so that when it comes time for the test, you actually know how to do it. All right, good luck, guys.